Hello friends, very good morning. Myself Dr. M. Chennaiya, and in today's video we are going to work out the section and development of a pentagonal pyramid which is resting on HP on its base such that one of the base edges of the solid is parallel to VP and nearer to it, and it is cut by a section plane which is normal to HP parallel to VP. It's cut by a section plane which is parallel to VP at a distance of 10 millimeters from the axis. The section plane is parallel to VP and at a distance of 10 millimeters from it. So very obviously when it is parallel to VP, it has to be necessarily perpendicular to HP. So this is the section plane I have marked here. I will call it as S and S. And for this position, let us name the corners as A, B, C, D, E. This is A, B, this is C, D and E. And here friends, we will transfer all these points to the front view and you are going to get A dash, this is B dash, C dash, this is D dash in the center and this is E dash. The axis is perpendicular to HP now, and here these OA and OB are not visible, hence they have to be shown by a dotted line or invisible lines. So these two slant edges are not visible. Friends, the height of the solid what I had drawn here is of 65 millimeter height. 65. We have to show the dimension where the height is shown. And with this friends, the object is being cut by section plane like this. So at distances of so much 10 millimeter from there. So it is cutting the base edge DE, base edge CD and also the slant edge OD. Now friends, for this position, let us see what we get in the sectional front view. Friends, here ED is cut here. It is on the base. Base is this line. ED. E is here, D is here. You write a vertical line from there. So this is the point where ED is cut. On the same line, on the other end, this CD is cut. So we can mark it very close to that. These are the 2 points. Then friends, you have got OD, the slant edge being cut by the section plane. But here friends, OD, to get the true length of that, what I do, to locate this point here on that OD, I just draw a horizontal line till it meets the 45-degree line, take it upwards till here. Now the height is known to you. Since it is kept like this, inclined to wall, in the end view, you will be able to see the true length. That's why I am going to construct the figure to get the end view of that. Friends, this is our D double dash. This is D double dash. And here, the true length of this slant edge is to be obtained. So let us get what is called the vertex or the apex of the solid. This is the apex of the solid. Listen carefully, friends. This OD is inclined to wall just like a ladder inclined to wall. And this will give you the true length here. So friends, in the end view, this is D double dash, this is O double dash. And if you join these two friends, you will get what is called the true length of this slant edge of the pyramid. So with this true length, I will just mark it dark so that you can see clearly. So this is the true length you have got, friend. How to obtain that, friend? It is cut here. OD is cut here. We have shifted that OD or shift that to 45-degree line. From there, write a vertical line upwards to cut O double dash, D double dash at this point. From there, friend, draw a horizontal line like this. And you are going to get this point on OD. So this is a very nice problem. So without this concept of the true length, you cannot solve this problem at all. Friends, these are the 3 points, and we will show these 3 points as 1, 2, 3. This is 1, this is 2, 2 on this, 1 on this, and this point is 3. For all the pyramids, these are to be joined by the so-called straight line. So I am going to join this like this, second from here, third here, and friends, I am going to section it or hatch it by lines drawn at 45 degrees to the horizontal. This is how this section looks. And friends, this particular hatched area that we obtain here is the true shape of the section. Because remember, whenever a solid is being cut by a vertical section plane parallel to VP, the true shape you get is called the true shape. This is the true shape. So just mark here and say this is true shape. So we have got the true shape, and let us see what is the portion that is left over after this is being cut. So in the front view, friends, I will mark this line, this, the end line, another line, points here, and here this portion is removed. So I will represent the remaining part of that by visible lines. So till here it is retained. This line edges OE, OA, OB, and OC are also retained along with this shorter portion. This bottom portion of the solid is removed. And friends, we call this as the sectional front view, SFV. And this hatch portion will give you true shape of the section, and it is going to be a triangle. Friends, this whatever you have below the XY line is called the top view. So you have the sectional front view, you have the top view, and have explained clearly how to obtain the true length of this line generator. So even this part is to be shown by a full line. Now friends, after obtaining the sectional front view, the top view, let us see how to draw the development for this same pentagonal pyramid. Friends, remember, always the developments are drawn to the actual dimension or the true dimension. So to draw the development of a pentagonal pyramid or any pyramid or cone for that matter, you need to find out the true length. This true length have got already, you know the measurement of that. Using that true length, friend, I am going to write a vertical line, say O under the true length, and draw a sector like this, and on that sector I am going to step off 5 divisions. This has got 5 edges, so this is 30 mm. So I am going to step off 5 divisions, 1, 2, 3, 4 and 5. Join all these to O, the vertex. This is 1, second, third, fourth and fifth. And for all these pyramids we have the straight edges. So let me show those straight edges from all these. Straight edge it has got, straight edge, straight edge, straight edge, again straight edge. Now friends, to obtain the development of the pentagonal pyramid, we have to see from where should we start the development. Here as you see the figure, there are 5 slant edges, OA, OB, OC, OD and OE, and none of them are totally removed by the section plane. In other words, you have the provision to commence the development from any one of these slant edges, OA, OB, OC, etc. So let me start this from OA. This is OA, OB, OC, OD, OE, and again OA, because starting and ending lines should have the same marking. If it is from OB, ending should be OB. If it is OD, ending should be OD, and so on. Friends, on this development, we need to have only 3 points which are marked as 1, 2, 3. So friends, how to mark them? 1, 2, 3. Friends, if you see this, the point 1 is on ED of the base edge. So this is a 2 dimension. So on AD, you take this measurement E21 on ED, take that measurement between E and ABCD, E and D, nearer to E, on ED, nearer to E, on ED, nearer to E. So I'll just mark this point somewhere here. That is one point. On the same lines, we have this point, say point 2 is on CD nearer to C. On CD nearer to C. So same distance you should mark. So you have marked these two, friends. This is point 1, this is point 2, and finally, friends, this point 3 is on what? It is on OD. But this is not the true length. OD, you have the true length here, and on O double dash D double dash, you can take this distance and mark on OD. That's going to be little higher. Friends, we have got all the 3 points, 1, 2, and 3, and we are required to join these by straight lines. So I am going to join 1 to 3, then 2 to 3, and this portion of the solid is totally removed because D portion is removed, it is not existing. So show the remaining lines like this. So I am going to have this OA is existing. So show by dark line. Then this is existing. OA again. And OB, if you see, friends, OB is also there. So OB should be shown by dark line or visible line. So what we have shown, OC is also existing, and then OE is also retained. And friends, for all the pyramids, as I told you before, all the base edges are straight. So I have to show this by a straight line. This is by a straight line. This edge by a straight line. Portion up to here, straight line. This portion, straight line. Finally, this has to be straight line. And friends, you need to retain all these construction lines. So do not rub them, show them. So this is how, friends, we are going to get the development of the pentagonal pyramid, which is cut by a section plane parallel to VP and perpendicular to HP. So friends, please go through the complete video without skipping anything in between. And if you are happy with the presentation on this problem, wherein we have worked out the section on development of a pentagonal pyramid, which is resting on HP on its base with an edge of the base parallel to VP and nearer to it. Friends, I thank you very much for watching my YouTube video.